You know, in the incredibly complex world of chemistry, and especially inside our own bodies, stability isn't just a nice-to-have, it's literally the key to survival. Today, we're going to pull back the curtain on the unsung heroes that maintain this delicate balance, the body's invisible chemical shields.
So let me ask you something. You can drink a glass of acidic lemon juice, right? But your body's internal chemistry barely even flinches. How is that possible? Well, this is what we might call the lemon paradox, and the answer to it reveals one of biology's most brilliant secrets.
And the answer is something called a buffer solution. The best way to think of it is as a chemical shield, or maybe like a bodyguard for your body's pH. It doesn't stop change completely, but it acts like a shock absorber, making sure the environment stays stable when a little acid or base shows up.
Okay, here's an even simpler way to picture it. A buffer is like a chemical sponge. Its whole job is to just soak up any extra acid or base ions that get introduced, which stops the pH from going haywire. And, the more concentrated the buffer is, the bigger the sponge and the more it can absorb before it gets totally overwhelmed.
So, how do you actually make one of these chemical sponges? It's not just any random mix of chemicals, that's for sure. It's a very specific two-part recipe that gives it this amazing ability to neutralize both acids and bases.
The magic is all in the pairing. You need a weak acid teamed up with its partner, which we call its conjugate base. Or you can do it the other way around, a weak base with its conjugate acid. This team is absolutely crucial because one part is on standby to neutralize any incoming bases, while the other part is ready to neutralize any incoming acids. It's a perfectly balanced defense system.
In a chemistry lab, this might look like mixing acetic acid, yep, the stuff in vinegar, with its salt, sodium acetate. Or you might mix the weak base ammonia with ammonium chloride. It's this specific pairing that gives the buffer all its power. And scientists don't just guess at the amounts. They use a tool called the Henderson-Hasselbalch equation. Think of it like a super precise recipe that lets them calculate the exact amounts they need to create a buffer that holds a perfect pH target.
All right, now let's take this concept and see where it matters most, inside our own bodies. This isn't just some abstract chemistry anymore. The buffer system in our blood is performing a constant, high-stakes balancing act 24/7.
This right here, this is the magic number. The pH of your blood must be kept within this incredibly narrow, razor-thin window, somewhere between 7.35 and 7.45. If it strays even a little bit from this range, your body sounds all the alarms.
And here's exactly why those alarms go off. If your blood pH drops below 6.8 or manages to climb above 7.8, it can be fatal. The margin for error is practically zero. So the big question is, why is the body so incredibly strict about this?
Well, it all comes down to proteins, specifically enzymes. These are the microscopic workers running every single chemical reaction in your body. But here's the catch. Their ability to do their job depends entirely on holding a precise 3D shape. If the pH changes too much, they denature. They basically unravel and lose their shape, which shuts down your body's entire metabolism.
So how does our blood pull off this amazing feat of stability? It's mainly through this system right here, the Bicarbonate Buffer System. It's this beautiful, dynamic equilibrium. If you get an increase in acid, that's the H+ ions, the whole system just shifts to the left, converting that acid into carbon dioxide, which we can then just breathe out. It's a totally elegant, self-correcting machine.
And this brings us right back to where we started, to our lemon paradox. When you drink that lemon juice, the bicarbonate ions in your blood immediately get to work and just gobble up all those extra acid ions. Your internal shield works perfectly, protecting that delicate 7.4 sweet spot.
But here's the thing. These chemical buffers aren't working alone. They've got a really powerful support system. Our own organs step in to make sure that chemical shield never gets overwhelmed. This is where chemistry really meets physiology.
Think of your lungs as the rapid responders. If your blood gets too acidic, you just start breathing faster. You exhale more CO2, which pulls acid out of the blood and raises the pH in a matter of minutes. Your kidneys, on the other hand, are the long-term managers. They work much more slowly, over hours or even days, to permanently remove acid by putting it into your urine and reabsorbing bicarbonate to basically recharge the buffer sponge.
Now, this whole system isn't just trapped inside our blood. Once you know what you're looking for, you start seeing these amazing chemical shields absolutely everywhere, playing a huge role in our daily lives and even in the environment. Have you ever seen buffered aspirin at the pharmacy?
That uses a buffer to neutralize some of the drug's own acidity, which helps protect your stomach lining. Buffers are also critical in things like brewing beer and preserving food, where they create a stable pH for yeast and good bacteria to do their jobs. And here's what's truly amazing. Our oceans use the exact same bicarbonate buffer system as our blood to protect all of marine life from acidification. It's wild.
So, from a simple glass of lemon water all the way to the vast oceans, buffers are these invisible heroes that are constantly maintaining stability. It really makes you wonder, doesn't it? What other elegant, invisible chemical systems are silently working right now, keeping our entire world and us in perfect balance?